Okay, for this section, 2.8, we're going to talk about the distance formula, the midpoint formula, and then circles, okay? So the first thing is the distance formula when you're finding the distance between 2 points in just your traditional coordinate grid system. The formula is given by D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? And I'm going to write this down over here on our other board. And so one of the things to note here is that this is a scenario where knowing how the formula came about actually provides a secondary way to be able to find values for this, okay? So they're asking us to find the distance between -1, -3, and 2, 3, okay? So now then, so we're going to plot these 2 points. So I've got -1, -3, it's going to be here. And I've got 2, 3, which will be here. And we're now looking for this distance, okay? Now, where this came from, okay, this whole formula thing came from, is they built a triangle out of this, okay? Now, certainly, one option is that I can just count squares. So this is 1, 2, 3 units. And this is 1, 2, 3, 4, 5, 6 units. Now, the thing of note here is that this is a right triangle. And we know that it's a right triangle because we have a vertical against a horizontal line. And we know those are perpendicular, meaning they have 90 degrees. So I can count the vertical and I can count the horizontal. But another option would be to take the 2 x values here and subtract them from each other. Notice here they're taking the x values and they're subtracting them from each other. And that would give me the length of that side. Now, I would do a similar thing here with the verticals, okay? And I could take the 2 y values and subtract them, and I could figure out the length of that side. Now, the one formula that we know for a right triangle is a squared plus b squared equals c squared. Now, when this is set up, though, a and b are going to be the horizontal and the vertical for this, and c is going to be that hypotenuse side, or c is going to be the length, okay, that distance. But I don't want c squared. I just c. So we're going to have to take a square root to get c by itself. Now, again, though, we said that a was this horizontal and we could subtract what it was. Notice there's the subtraction squared, okay? Then we have b squared, which is our vertical. But again, we said we could subtract to get that. And there it is squared. So this came from this a squared plus b squared equals c squared. And then they moved the square root over. Now, this is one where I'm a little more visual, okay? So I'm going to do 3 squared plus 6 squared equals c squared. So I have 9 plus 30 equals c squared. So I've got 45 equals c squared. I'm going to take a square root of 45. I'm going to break that into 9 times 5. That's not a square there, sorry. And then I can take the square root of 9 is 3. Square roots of 5 equals c. So here's what this would be in reduced form. We can then put that onto a calculator, and at 2 decimal places, that is 6.71. So you have your choice here. You can either draw a picture and go back to traditional, Pythagorean theorem, a squared plus b squared equals c squared, or you could plug your values into the equation and you would get